Hi everybody. I wanted to give you a little overview of annotation. In annotation, we have an opportunity to add semantic information to our Java code, and that information can be checked by the compiler. In order to get semantic information into the code, first we want to motivate it, and the basic question is, what is semantics? And the answer is semantics are the difference between the grammar and the usage, right, and the meaning. So for example, if you said double x, we don't know the range on x. We don't know if x could be 0. We don't know if it could be negative. We don't know if it's supposed to be a number from 0 to pi. How can we know these things? And so what we want to do is we want to come up with a mechanism for defining ranges. So here what we'll do is we'll establish first an annotation called retention, which means that we're going to be able to take our statements about semantics and store them in the bytecodes. And the second thing we want to do is we want to establish a range for our elements, and we also want to be able to establish some sort of display value. So what we'll do when we say get value is we'll establish a default value, and when we use the name, we'll use a display name. So here we have a thing called Boolean range, and in the Boolean range we only can have a Boolean value. And knowing this in advance will help us to formulate not just a graphic user interface object such as a checkbox, for example. We'll also be able to make it so that it is checked by default. And so here is some dumb variable called setDumb, and we'd like to be able to build a graphic user interface for it automatically. We could use HTML, we could use Swing, AWT, SWT, and whatever we like. Here's one for colors. We'll just use a string for the foreground and background colors. And here's one where we use the string as a 24-bit hexadecimal quantity, then in the order of red, green, and blue. That's 2 nibbles each, so 0, 0 would mean red has no value, whereas green FF means that, let me get this pointer out here. And this would be the green FF, which means its maximum value. So now it says foreground is green. So then we have another thing called the Boolean range. So now we've got a foreground and a background associated with setDumb, which allows us to be able to give you a graphic user interface with some sort of coloring. Here's an example where we have a double precision number in range, and we can get the value, the minimum, the maximum, the increment, and the name. And somebody might be tempted to say, well, why don't we just use a spinner number model? And the answer is, well, that's a new instance, whereas the double is just a primitive data type. Moreover, there is no extra cost to the runtime for the program by adding something about the range that's being used for a double that's coming in as an argument. So it doesn't slow the program down at all. So here's an example where we have the range. We've got the minimum and maximum, a default value, a name that would appear for the variable, and an increment that could be used. For example, a spinner could increment by 1. So now when you set y, you know it's a number between 1 and 100 with a default value of 50 and a display label of hello world. Meanwhile, if you wanted to just use the business logic for setting y or doing some kind of computation with y, this annotation doesn't slow you down at all. So here's another example where we've got a range array. Now we've got a whole series of different names which it can be used for a series of different values with increments and maximums and minimum and values, and presumably it's homogeneous and therefore they all have the same range and the same default value. So here's an example where we have the red minimum, the red maximum, blue min, blue max, green min, green max, an increment of 0.01, and now we have single precision floating point corner points, which can be used for defining some sort of color space. Now the question is, how would you like to formulate the graphic user interface for that one? That's another matter. So if you think about something like spinner properties, you can take spinners and add additional properties such as whether or not they're compacted or whether their increments are hidden or not. And you can make compaction something that's false so they can be spread out a little bit. You can make the increment hidden false so that you can have an increment and up-down arrow. And then for visibility, you might want to make it true. So when somebody sets Z, they can have some spinner properties, so when a spinner number model is created, we have some guidance on how to create it. I think the directive on, the guidance for how to create it and the details of how to implement it should essentially be separated, and that's the goal here for this kind of declarative programming. We would like to get some default size and some display name for text properties, and we can declare what these things are. The question of how you're going to implement a graphic user interface is a completely separate issue. So here we have some display name based in a Greek letter, so we surround it by curly braces, and the question of how to select proper font, make it appear as though rho looks like a Greek character. That's one of those things that we should be able to automate. And so that's what we've got for our annotation scheme.